Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will discuss a very important proof that zeta of G means center element of G. Center of G is contained in centralizer of G, centralizer of X in G, and the centralizer of X in G will contain in neutralizer of X in G, and neutralizer of X in G will contain in whole G group. So let's start. Very interesting and very important proof it is in group theory. Let's start. The theorem is, let G be a group and X be a non-empty subset. Then prove that we know that in centralizer, in neutralizer, and in center we take a non-empty subset, not group, subset of G. Some elements of G we take and commute them with the elements of G. If the whole set commute with G, that is called normalizer. If every element of G commute with X, every element of X, then it is called centralizer. And if every element of G commute with itself, if any element of G commute with every elements of G, that is called zeta, or that is called center of G. If you want to understand deeply neutralizer, centralizer, zeta of G, you can watch my previous lectures through my channel. So let's start. As we have already proved, we have no need to prove that G, these are all contained in G, because these are all the elements of G. So no need to prove that these are contained in G. We have only need to prove that this portion, that zeta of G and center of G contain in centralizer of X in G, and this contain in neutralizer of X in G. Let's start. As we know that zeta of G, let Y belongs to zeta of G. If Y belongs to zeta of G, means we take here X as well. X and Y belongs to zeta of G. So X and Y will surely commute with each other. So every Y in G will commute with every element of G. That's why it's called the center of G. So they must commute. So it is in the definition of center of G. So xy will commute with xy. So yx is equal to xy for all xy belong to x comma y belongs to G. As yx is equal to xy for all x belongs to x and x is contained in G, it means that the y belongs to centralizer of G as well, because all the elements in centralizer are also commute with the elements of G. So elements of G commute with the all elements of X, which are centralizer of X. This prove us, or this give us the result that Y is also belong to centralizer of G. So it means that the center of G is contained in centralizer of G, because we take a general element Y that belong to center of G and it also belong to centralizer of G. It means that all the elements, because these are the elements which surely commute with every element of G, so they will be also present in centralizer of G. Now let Y, we take element Y belongs to centralizer of G, and for the centralizer of G we know that every element of G commute with every element of X, those elements of G are make the centralizer. That's why this element Y will be equal to xy, yx is equal to xy, where this x belongs to x, because in centralizer of x we take element from G and that commute that element with every element of x. If commute every element of x, then it is the centralizer of x in G. So yx is equal to xy, and we know that as x belongs to x, so y also belongs to whole x, the group x, or the subset we have taken x. So yx such that x belongs to x, it means that it was the minor difference between centralizer and normalizer, that elements commute with whole subset are called, if they commute with the whole set they are normalizer, if they commute with every element of subset they are centralizer. That's why this small x is present in capital X element of subset x. That's why this yx is equal to xy. Here we prove that if y belongs to centralizer, then y is also belong to neutralizer. So centralizer, every element of centralizer will be in normalizer of G. So by combining the results, the center of G will contain in centralizer of G, and these are the elements of centralizer of G contained in normalizer of X in G. So hence proved that the center of G, the elements which commute with every element of G, contain in centralizer of X in G, that if we take some elements from G and commute with every element of X, those elements are in centralizer of G, those elements are same. So these elements must contain in this. So this centralizer contain in normalizer of X in G, because in normalizer we take some elements from G and commute them whole subset X. That's why these all elements surely contain in normalizer, and we know that all the elements of normalizer are we have taken from G, so these are also contained in G. I hope you understood. Thank you so much.